Hi, and welcome back. This is like the second video, and today what we're going to do is we're going to go over some filament. Filament is the plastic that we use for the 3D printing. On there's many different kinds of 3D printing. There's laser and liquids, and we use what most everybody, like say 90% of either classroom use or home use is using a plastic filament. Kind of, we talked about this in the last video. It's kind of like a glue gun laying down glue on layer after layer after layer. And today we're going to focus on the filament. So sizes of filament, types of filament, where I can get it, colors, exotic filaments, and some crazy, crazy stuff. So the last video we talked about how do you bring in a model, CAD model into an STL and and then what do you do with the slicer and then printer. And I want to really focus on the filament this time. So if you go back to the Google Classroom, which I had you set up in the first video, there's a link here. For 3D printing filament. And what it does is it brings you to this right here. And I don't know Nick, or I don't really don't know the editor of this. What I really thought was interesting was it was kind of a guide for ABS and PLA and then other exotic type material for filaments. So the first one is ABS, acrylyl nitrile butadiene styrene, and that's just a big fancy word, but it's a petroleum-based type plastic, and it's generally and melts consistently around. It says 225. I use 240 degrees Celsius in the classroom, and you say Celsius, right? What is that, the Fahrenheit? I don't know. I could look it up real quick and change it. Convert it, but most all machines, I think they use Celsius. So when you're talking about degrees where it melts, consistently 225, mostly 240. I use 240 degrees, and this is a great plastic. It's really strong. You can dissolve it in acetone, which has some interesting properties. This on the left hand side, this owl here is not dipped, but it has a vapor of acetone, which is what nail polish remover. So it did look like this on the right hand side, and it can be moved to this. It's kind of some interesting stuff, but it's probably the nicest, strongest, easiest plastic to deal with, ABS. All right, and then there's some issues here, right? So when it does lay down, it likes to pull or warp. They call it warping, and you can see it right here, ABS warping. And unfortunately, with temperatures as it cools, it likes to warp, and ABS does that quite a bit. All right. And then there's the other plastic that we use. So there's ABS is pretty much the primary one. There is PLA. So PLA is like a sugar derivative type plastic or polylactic acid. It's way different. I mean, it has a melting temperature much less. We usually use it around 190 to 205. This is up to 210. ABS does have kind of an off gas smell to it. Take a look at that, especially if you are using it in the classroom, what your district prefers. In a lot of elementary schools, we like to use PLA. It doesn't have an off-gas smell to it, and people are worried about VOCs and ultrafine particles, UFPs. Take a look at that. ABS, like I said, isn't a petroleum-based plastic. It does have a little bit of a plasticky smell when it melts. So if that's not something you want in the classroom, definitely take a look at PLA. PLA is not as strong of a plastic, but it doesn't warp as bad either as ABS. You really have to find what works for you. We use mostly ABS in the classroom here at Ceres High School. We do use some PLA for some printers that we have that don't have a heated bed where warping is really bad. I use PLA because PLA doesn't work as bad as ABS. So it talks about the smell, right? It doesn't smell as bad. It actually kind of smells like I don't like candy when it comes through. Is the sugar derivative plastic. I mean, it's really interesting, but it has its own smell to it. It's kind of interesting. Doesn't warp as bad. You don't need as much heat, etc. Right. So that's PLA and ABS. PLA doesn't dissolve in acetone, which is really interesting. So you can do that nice shiny. We looked at those owls. You can do that nice shiny thing here with acetone. And you can make it kind of melt a little bit. In fact, it'll melt all the way down to nothing with acetone, which is nail polish remover. But here, the PLA doesn't do that. It doesn't do that at all. So you have some issues. Maybe if a nozzle clogs, if you're pushing it through sodium hydroxide, you got to be careful with. Bases like that, but you got to be careful. But you can use that to help clean it up. All right. So the two basic plastics, ABS and PLA. And I think I have a slide on that here. Let's take a look at the slides. There we go. So ABS, I usually are around 240 degrees Celsius. PLA, anywhere from 190. I will use up to 205. Have some other things in here about ABS and PLA, kind of interesting. But those are basically the two types of plastics that I use in the classroom. All right, so if we go back here and we talk about types of filament, that's what we're talking about. There are some really other cool ones. Why don't we get into sizes first, and then we'll come back and revisit the other types, some of the exotic stuff that you can get. So kind of really cool. All right. So that's types of filament. Primarily, let's type that. We should type that in. ABS and PLA. All right. ABS, PLA. ABS, petroleum based, PLA, sugar derivative, high temperature, strong plastic, low temperature, not as strong of a plastic, but still pretty good. All right. So sizes. So there's many different types of sizes. It really depends on your machine. I have these down here only because that's what I use in the classroom. So I have the Up Mini. I have an Up Mini 2. I probably should put that Up Mini 2. We have the Up boxes now too. I probably did this a couple of years ago, man. We have some really new stuff, some great pieces of equipment. Affinia and Zortrax. So I'll use 1.75. And if you look at that, they're much smaller filament sizes. The thickness, the diameter of the filament is 1.75 millimeters. And most of the machines that we use is 1.75. And remember, all of these here, they come in both ABS and PLA. So we can use 1.75 millimeter ABS or PLA, 2.85 ABS PLA, 3 millimeter ABS PLA. You got to be careful, especially when using a system like an Airwolf or something else, which has 2.85. 2.85 millimeters is really close to 3.0 millimeters, but it's not the same. You try to jam this into one of these idea printers, it doesn't work very well. It just doesn't push as much plastic as it needs to. And oh man, if you try to push a 3 millimeter through 2.85, it's just going to gum up the system. So be careful when you're using the machine. It will tell you. And generally they give you a half a kilo or a kilo size of plastic filament that comes with it. Take note of that and just make sure you're using the right stuff. All right. So we talked about types of plastic. Here's 3 sizes of plastics and what we use them for. Most of the stuff I use in the classroom here at Sirius High School is 1.75 millimeter. My Airwolfs use 2.85, and my Velamin Idea printers use 3.0. And I generally run mostly PLA in this stuff, and then ABS in this stuff right here. Okay. So what else we got? Where can I get filament? So what I like to do, one of my best suppliers is Octave. They're here in Santa Clara in California. And they're local to me, and I can get stuff really quickly. So if I do a Google for Octave systems, Octave, you see it here, and then I click on it, octave.com. Right there you go. So there's some. Oh, what did I do? Look back home. Go back. Did I click it? I was so excited. All right, so there's some filaments there. What I'm going to do is I'm going to bring up this 3D printer filament, and look at all that stuff that you can get. So they have ABS. So they have their own brand. Octave has their own brand of filaments, and I use their Octave ABS. Octave PLA. I haven't used much of their PLA, but I use a lot of their ABS. They have precision, regular PLA. There's kind of like a blend now, like a PLA PHA that you can use, and I think I wonder if that's what it's talking about. PHA PLA. It says precision, so I'm not sure if this is PHA PLA. Does it say up here? No, it doesn't. The temperatures aren't the same, but it's a little bit stronger of a plastic from what I understand. I haven't used it, but there's some other stuff, PETG, so some exotic stuff. Click on that. What do you got? So some PETG stuff. I don't really use a whole lot of that. What does it say? Combining strength and flexibility to produce product. That's high impact resistance. Wow, that's good stuff. You kind of got to look at this too for the temperatures that you need. Remember, we were just talking, but most of the stuff that we use is ABS and PLA in the classroom. They do have Affinia, so this is just another brand of ABS PLA. They have some specialty filaments in here, and then you go the Fila ABS PLA. This stuff's really cool. The Zortrax, they have a Z ABS, Z Ultra. This is just really good, high quality plastic. Of course, so let's look at Octave ABS, right? So you can get this. I don't know. They have some good specials. At 2 rolls, so it's like $26 a roll, or hey, 4 of them for $100. That's actually really good. So you're looking at about $25 a roll. Not bad. Then some of the other colors and stuff, if you want. And then if you go over here to the Zortrax, probably a little bit more expensive. It's a little more expensive, yeah. So 2 rolls, 59, a little bit more expensive, but this is a higher quality too. So we're talking about colors. We're talking about, and I'm running out of time here, colors. Where can I get the filament? We talked about Octave. And what I'll do is I'll come back and finish up the filaments and go into some of the other cool stuff. All right. Thanks so much.